Hello there, this is Alana Tucky, and I received a question about this problem from the homework, which would be 3.4, number 29. If you look at it in the top right corner, you'll see those numbers there. Where it is in your particular homework set, of course, is anybody's guess. All right, so let me click on an example here so we can work through that. So we have the accompanying pulse rate data represents the pulse rates beats per minute of 9 students. Treat the 9 students as a population. Compute the z-scores for all students. Compute the mean and standard deviation of these z-scores. Click on this table. Okay, so I click on the table and I can see the students right there, and I'm actually going to copy it to my clipboard and paste it into Excel. And again, not because you have to use Excel, because you don't. It's just a convenient way for me to type for you so you can see what I'm doing, because I don't have the luxury of a piece of paper when I'm working on my computer like this. All right, so I have all the students here, and I want to find their mean and their standard deviation because I won't be able to find their z-scores without it. So I need to know the mean and I need to know the standard deviation. And I want to treat these individuals as if they're a population. So let me go grab my calculator. Stat number 1. I'm going to go up and clear out my old data, enter, and move left and then up, clear, enter. And now I want to enter this new data set. So 72, oopsie, 75, 62. All right, there are the numbers in there. Now, let's see, stat, calculate, number 1. My data is in L1, so there you go. I'm going to move down to calculate and press enter. And the mean is 72.2, and the standard deviation, now you have two options. You have S and sigma. But because they said this was a population, I'm actually going to use the sigma value, which is 7.465. So the mean, and I'm just going to be cheating about this and use the Excel to do it. So it's 72.2222. And the standard deviation, because it's a population, I have to use sigma. So that would be 7.465. You can use your calculator to do this, obviously, and you could just type in the values if you so desire. There we go. So now you can see this is 72.222. This is 7.465, roughly. All right, now we need to find the z-score for every one of these individuals. So we want to find the z-score for 75. Let's start there. So remember that the z-score formula, actually, let me go type that up 1 second. There we have it. So the z-score formula is x minus mu over sigma. There's the general formula. So I want to use that formula for all of my values. Let me make this bigger so you can see it. There we go. Okay. All right, so I want to find that for each of these numbers. So I can use my calculator to do that. You can do it a couple ways. You could say parentheses 75, take away 72.222, close your parentheses, divide it by 465? 465. There's one. And that's your first one. So you can say, okay, this z-score is 0.372. And then you would do it again. Now the other way to do this is alpha F1 and pick number 1. This is only an option for people that have the newest operating system, but it's a little bit nicer because it looks more like it does on the paper. So you can say numerator, which is 75 minus 72.222, divided by the denominator of 7.465, press enter, and you get the same number. And then you just want to do it again and again. So one way to kind of help yourself is to do second enter. It's entry, it's above your enter button. And you can see it has the same formula we just used. And you can go into it with your left arrow and then kind of move up with your up arrow to get over to the denominator, and you can change this number to the next number you needed. Oops, I went too far, which is 62. So I can try 62, enter, and find that that one's negative 1.369. And then you'll just keep doing this over and over and over. In a way, it's almost easier just to do alpha F1, 60 minus 72.222 over 7.465, and so on. And then you're going to find all your values like this. So this one would be negative 1.637, and so on. So you find all your values like that. So let me go find all of these. 1 second. It occurred to me it might be nice for you to know how to do this with Excel if you so desired. So it would be equal to parentheses this cell minus your mean, close your parentheses. You want to give your cell with your mean dollar signs, so you want to kind of move back into the B12 and press the F4 key, and it'll make it $B, $12. Then you divide it by this cell, and that cell also never changes, so I press F4 again to give that dollar signs. The only thing I want to change as I move down is the B2. And then if I drag that cell down, I move to the bottom right corner where that little dot or block, little box is. It turns my cursor into a plus sign, and then I drag it down. And there we go, I have all of them. It's more decimal places than I was really looking for, but that's okay. It'll work. So that's how to make Excel do it if you so desire, or you can sit there with the calculator and type them all in. It's fine. All right, once we have this, these are all of them. How many decimal places did they want in this problem? So done with that. Oh, they only want 2 decimal places. Okay, so we can do 2. So that means that this has to be 72.22. This is 7.47 if we round. And then these would all be 2 decimal places, like that. All right, now that we have all of our z-scores right here, we need to know the mean and the standard deviation of those, because I think it's asking for that next. So we have all our z-scores, and then it wants to know the mean and the standard deviation of those z-scores, and I think the variance as well. Nope, just the mean and standard deviation. So I could enter these data into L2 and find that. So stat, number 1 for edit. I'm actually just going to put them over here in L2. And then let's see here. We have 0.37, and then the negative symbol's down here. So negative 1.37, and so on. All right, so we have those values in there. And then I'm going to press stat, calculate, number 1, one variable stats. And I'm going to tell it L2, so second 2. Leave the frequency list blank and go down to calculate and press enter. And it tells me that the mean is negative 0.001 and the standard deviation is 0.9997 or 1.06 if this was a sample, but this is a population. So when we look at those values again, real quick, this is basically 0, right? It's rounded to 0. And this score down here is basically 1, right? 0.99979, that's 1. So the mean is roughly 0 and the standard deviation is roughly 1. If we kept more accuracy as we went, it would have been a little bit better. But because we rounded all the way along, it makes it a little bit weaker. In case you're interested. There. The Excel is actually storing for us all the decimal places because of the way I did it. So if we use all these decimal places here, you can see that it knows that it's 0. And then the standard deviation, if it's a population standard deviation of these values. See? I didn't catch all of them there. There. It's 0.9999935. Right? Very, very, very close to 1 because it basically is 1. All right, so we're all set with that problem. All right, so I hope that helps. You find the mean, you find the standard deviation, right? Then you find the z-scores for each one. So you take these values, you find your mean and your standard deviation from those values. Let me highlight those. Then you find your mean and your standard deviation. Then you use those to find all your z-scores. And then once you have all your z-scores, find the mean and the standard deviation from that. And you can use Excel or you can use the calculator. It doesn't really matter. If you're in a face-to-face class, you're more likely to use a calculator. Online students can use either. Doesn't make any difference. But you'll be able to find the z-score for everything and then find the mean and the standard deviation from there.